Dear students, this session we are going to study about curve fitting. Curve fitting. What is curve fitting? Curve fitting refers to finding an appropriate mathematical model that expresses the relationship between a dependent variable y and a single independent variable x. Okay, simply curve fitting means finding a mathematical relationship between given data. Right? For example, consider the following data between x and y. So here x values are 2, 3, 5, 6 and 8. Corresponding y values are 17, 25, 41, 49, 65. Okay. The mathematical model between x and y for above data is y equal to 8x plus 1. Right. For example, if we put x equal to 2 in this equation, we can easily find y equal to 17. Right. Types of curve fitting. There are two types of curve fitting. One is method of least squares. Another one is interpolation. Method of least square. What is method of least square? For discrete values, derive a single curve that represents the general trend of the data. Now see the diagram here. So there are some dotted points here and a line is passes to very close to all the points, right? Here never touches here. Okay. Whereas in interpolation, for discrete values, fit a curve or a series of curves that passes directly through each of the points. Here also we have some dotted points. Okay. But curve passes through all the points. So this is the difference between method of least square and interpolation. Okay. Now method of least square. So first we are going to study method of least square. First, procedure for fitting straight line. Okay, so we are going to fit straight line model here, right? So what is the model here? Y equal to a naught plus a1x. A linear model. The unknown values are a naught and a1, right? The given data are taken as set of paired like this: x1 y1, x2 y2, xn yn. Right? First, we define the error term as yi measured, that means actual value, minus yi model, that is this value. So we get this equation. Okay. Now condition for best fit is minimum of sum of squares of errors. Okay. So minimum of means a naught a1 summation I running from 1 to n yi minus a naught a1 xn the whole square. Right. So here we are going to apply maxima minima condition. What is the condition for maxima minima? For several variables. First, differentiate partially with respect to one variable. Okay. And put equal to 0. Then differentiate with respect to another variable, put equal to 0. Right. Same thing here. So first differentiate with respect to a naught. Because a naught is unknown variable. If we differentiate with respect to a naught, we get like this and equal to 0. Similarly, if we differentiate this with respect to a1, we get equation like this, but here we have xi, right? Now simplify these two equations, right? From first equation, after applying summation, we get this equation, right? Similarly, from the second equation, we get this equation. The equation 3 and 4 are said to be normal equation to find a0 and a1. If we solve these two equations, we can easily find a0 and a1. Then we can easily fit the straight line. This is the actual procedure for straight line fitting. Now, steps for curve fitting. So, step 1, right, is choose the model to be fit for the given data. Right, first we have to choose the right model. Okay. So for example, y equal to a plus bx. Okay. Second step, identify the unknown values in the model. Right. So here we have four variables x, y, a, b. The unknown variable are a and b. Right. A and b. Then find a normal equation for a and b. Okay. Already we have seen in the last slide how to find a normal equation. Last final step, solve the normal equation to find values of a and b, right? Now, problems. Fit a straight line to the following data using method of least square. Okay, so here we have x and y values, right? So x values are 0, 1, 2, 3, 4. Corresponding y values are 1, 1.8, 3.3, 4.5, 6.3. Okay, right? So fit straight line. Okay, what is the mathematical model here? Y equal to a plus bx, because straight line means simply a linear equation, right? So first we have to identify the unknown variables. What are the unknown variables here? A and b. Then find the normal equation, right? So how to construct normal equation? Okay, very simple. First apply summation to the this equation. If you put summation here, becomes summation y. If you put summation here, summation a. Simply summation means number of values n into a. If you put summation here, b into summation x, because b is constant, right? So this is the way to find first equation. To find another equation, right, multiply by x. If you multiply this by x, become xy, and put summation, that is summation xy. Okay, if you multiply x here, we have x here. After putting summation, we get summation x plus, if you multiply x here, we get x square. Then after putting summation, becomes summation x square, right? So these are the normal equations. Here n represent number of data. In this problem, n equal to 5. Number of data equal to 5. Okay, right. Okay, to solve these two equations, we have to find a summation y, summation x, summation xy, summation x square, right? Okay, to find summation x, summation x square, summation y, and summation xy. First list the values of x and y. Okay, x and y. So values of x are 0, 1, 2, 3, 4. Then y are 1, 1.8, 3.3, 4.5, 6.3. Right, we have to find x square also. Put x square here, square all the values of x. 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. Then next column, find x into y, because we need summation xy, right? Find x and y, x into y, right? Means 0 into 1 is 0 here, 1 into 1.8 is 1.8, 2 into 3.3 is 6.6, 3 into 4.5 is 13.5, 4 into 6.3 is 25.2, right? After finding all the columns, find summation of all the values, right? We need summation x, that means add all the values of x. Summation x is simply add all the values, we get 10. Summation y, next one is summation y, that means add all the values of y, we get 16.y. Summation x square, add all the values of x square, that is 30. Similarly, summation xy, adding all the values, we get 47.1. Okay, now substituting summation x equal to 10, summation y equal to 16.9, summation x square equal to 30, summation xy equal to 47.1 in equation 1 and 2. So here in normal equations, right, we get equation like this. Okay, this is said to be normal equation. To find a and b, simply solve the equation, right? For this, first multiply equation 1 by 2. What happened? 10a, 20b, 33.8. Okay, now subtract these two equation. Okay, 2 minus 3 gives, what happened? 10a minus 10a cancel each other, 30 minus 20 is 10b, subtracting 13.2. So the value of b here is 1.32. Now substituting the value of b equal to 1.32 in equation 1. So what is the equation 1 here? 1 equal to 5a plus 10b equal to 16.9. Put b equal to 1.32. We can easily find the values of a equal to 0.72, right? Now we know the values of a and b. So what is the model equation here? Y equal to a plus bx. substitute the values of a and b here, right? We get best fit is y equal to 0.72 plus 1.32. Okay. Now example 2. Fit a straight line to the following data using method of least square. So here also we have two data, x and y. Okay, x values are 1996, 1996, 1997, 1998, 1999, 2000. Corresponding y values are 40, 50, 62, 58, 60. See the x values here, we have 4-digit number. Okay, so here also we are going to fit straight line. Okay, same model, y equal to a plus bx. The normal equations, we can easily find normal equations to find the values of a and b. Okay, first apply summation on both sides. If you put summation here, becomes summation y. If you put summation here, we have only summation a. Summation means simply n a plus, if you put summation here, b into summation x, because b is constant. Thus we get the equation number 1. To get second equation, first multiply by x, then put summation. If you multiply by x, we have xy here. Putting summation become summation xy. Here also, if you multiply x here, we have ax. If you put summation here, a summation x. If you multiply x here, x square. Putting summation, b summation x square. Okay, so here also n represent number of data. So here n equal to 5. Right? So these are said to be normal equation. To find the values of a and b, we have to find the summation x, summation xy, summation y, summation x square. Okay, right? Okay, first construct the table. Put x, y. So here we have x values as 4-digit numbers. Okay, use this as first capital Y here. Okay, this is actually small y, capital Y x here. Okay, list all the values. So this is small value 40, 50, 62, 58, 60. Okay, take the mid value. So what is the mid value here? 1998. Okay, small x equal to x minus 1998. Okay, now so what is the first value? 1996. If you put here 1996 minus 1998 is minus 2. Second value is 1997. If you put here, minus 1. Third value is 1998. If you put here, become 0. Fourth value is 1999. If you put here, 1. Last value is 2000. If you put here, 2000 minus 1998 is 2. Right? Then find the square. X square. Simply, minus 2 square is 4. Minus 1 square is 1. 0 is 0. 1 is 1. 2 is 4. Okay. Right. Then last column is x into y. X into y. That means this x into this y. 40 into minus 2 is minus 80. 50 into minus 1 is minus 50. 62 into 0 is 0. 58 into 1 is 58. 60 into 2 is 120. So finally add all the values. Okay, if we add all the values in y column, we get summation y equal to 270. If we add all the values in x column, we get summation x equal to 0. Similarly, summation x square is 10, summation xy is 48. Okay, now substitute these values in normal equations. Right, we get this equation 5a plus 0b equal to 270, 0a plus 10b equal to 48. We can easily find the values of a and b. Yes. Okay, solving these two equations, 5a equal to 270, a equal to 54, 10b equal to 48, b equal to 4.8. Right, now substitute the values of a and b in the model, mathematical model. Y equal to a plus bx, we get the required fit. Okay, suppose if we take entire x square here, we get 1996 the whole square. So we have to find 1996 square. Okay, if we use this technique, this number is reduced to minus 2, this number is reduced to minus 1. So we get one, we have to complete only simple square, so that we are using this technique here. If we have large data, we can reduce like this. Okay. Now, third example. Fit a straight line to the following data using method of least square. So here also two values are given, x and y. For x values, we have 5, 10, 15, 20, 25. Actually 25. Y values are 16, 19, 23, 26, 30. So here also the model is y equal to a plus bx. Okay. To find normal equations, the same technique. First apply summation. If you put summation here, summation y. If you put summation alone, represents simply n, nu. If you put summation here, b summation x. Okay. To find the second equation, first multiply by x, xy. Put summation, summation xy. There is no x term, therefore simply x is there. If you put summation, summation x. Next one is bx. If you multiply by x, become x square. Putting summation becomes summation x square, right? So here n represent number of data. So here also n equal to 5. Okay. So to find the values of a and b, we have to compute summation x square, summation y, summation xy. So this is actually small x. Okay. So the x values are 5, 10, 15, 20, 25. Y values are 16, 19, 23, 26, 30. Add all the values of x gives 75. Add all the values of y, so summation y is 114. To find third column x square, square the values of x. 5 square is 25, 10 square 100, 15 square 225, 20 square 400, 25 square is 625. Add all the values of x square become summation x square is 1375. Last column is x into y. That is multiply x in x and y. 5 into 16 is 80. 10 into 19 is 190. 15 into 23 is 345. 20 is 26 is 520. 25 into 30 is 720. Add all the values of xy gives summation xy is 1885. Okay. Now substitute all the values in the normal equation 1 and 2, we get equation like this. To solve this equation, multiply first equation by 5. So we get 1125a plus 75b equal to 1710. Then subtract 2 and 3 gives 250b equal to 175. Sorry, 270a equal to 175. That is a equal to 0.7. Substituting a equal to 0.7 in 1, we get b equal to 12.3. Therefore, the required fit is y equal to 0.7 plus 12.3 into x. Right? That's all.